Following on from the previous video, we are now ready to prove this theorem. So remember, our trick in the previous video was to visualize a series as this. So one way of looking at the series would be like this. Now, by you looking at it, by you viewing the series as this, it tells us that you're adding a positive amount, you're adding a positive amount, you're adding a positive amount. It tells us that it's going to keep on climbing. It's going to be non-decreasing. The reason why we say non-decreasing is because it could be like this. It could stay the same, and then grow, stay the same, and grow. But the point is it will never go down. It will be non-decreasing. And then by us looking at the very same series, but from a different perspective, this thing here tells us that it's bounded from above. It can never be higher than your initial term, your first term. So by you looking at the same thing, but from two different perspectives, it gives us two different information. So the first one would be us looking at it like this. But then for us to do it like this, we need an even amount of terms. We need an even amount. So we need. So let's look at. Well, you can't. But by you doing this, you can't really look at an odd amount. So if you have one term here, let's say 1/7, then here, well, in order for us to use this technique, we need to look at an even amount because they're being paired up. So let's look at a case where it's an even amount. So the trick that we're going to use is we're going to say let n be 2m. So this is a way of us communicating. Sorry, this is a way of me communicating to you that we are looking at an even number of terms. So for example, if you want to sum up this whole thing here, you would say s of 8. So, sorry, you would say s of 8. If you want to sum up to the nth term, you would say Sn. But then I could say the same thing here. So this is us summing up from 1 to the nth term. So me saying so rather than saying nth term, I could say 2m. So this is us saying the exact same thing, but it must be an even number of terms. So this is just a trick we would use. This is just a trick. So Sn here, I would write as S2m. So this thing here tells you that it's an even number of terms. If I want to say an odd number of terms, I would say this. So this is nothing more than me communicating to you that we are talking about an even number of terms. Okay, so hang on. So let's say we're summing up and an even. So it's this thing here. It's like me saying I'm summing up to the nth term. But rather than saying this, I'm going to use 2m because we can only sum up an even amount. So this is me communicating to you that we are talking about an even number of terms. Okay, so our first term would be u, second one would be u2, third one would be u3, and so on. But we are going to visualize it like this. Okay, so by us visualizing like this, we know we are going to get a non-decreasing. Well, it's going to be non-decreasing if you keep on summing up everything, because remember, looking back at our simple scenario, this here, if you add these two amounts, it will give you a positive. This thing here will give you a positive because this will always be bigger than this, so it will give you a positive. So here you're adding a positive amount, adding a positive amount, adding a positive amount. So it's going to tell us that it's going to be non-decreasing. Okay, so by you visualizing like this, it would tell us it's non-decreasing, and then visualizing it the other way. So looking at the at an even number of terms. So your first term here, and then you pair up everything else, and then right at the end you're going to get a loner here, right? Because you're looking at an even number of terms. And then your first one is single here, and then everything else gets paired up. So your very last one will be on its own here. Okay, so by you visualizing like this, you can tell that it's, well, here so you start off with your initial amount, you take away something, you take away a positive amount, and then you take away another positive amount, and then you keep on taking away. But remember, each pair here, this pair here is bigger than this. It gets smaller and smaller each time. So this one here will be smaller than this, and this one here will be smaller than this. So you start off with your initial amount, you take away an amount, you take away another amount, you take away another amount, it's going to be bounded from above. So by you visualizing like this, it's going to be bounded from above. So it's going to be bounded from above. So that's really you doing this. Hang on. So you got your first term here. Combine these two, that will then give you this. So look, you got one, take away an amount here, and then you take away another amount, and then you take away another amount. It's bounded from above. So hang on. So what you've got is, looking at it from one perspective, it tells you that you've got something that keeps on climbing and climbing and climbing. And then looking at it from another perspective, it tells you that you're bounded from above. So therefore, you know that the whole sum will head to some sort of limit, because there's a theorem that says that if you have something that keeps on climbing and is bounded from above, then it's going to have a limit. It will have a limit. There's a theorem that says that, but it's kind of obvious when you look at it, because you've got something that keeps on climbing and climbing and climbing, and then that very same thing is bounded from above, so it must have some sort of limit. Okay, it must have some sort of limit. So I will continue in the next video. So in the next video, we're going to look at the odd case. So all we've done so far is looked at an even number of terms. Now we need to look at an odd number of terms. Okay.